start with is like 5 plus 7. And I mean, they can introduce the order of operations this way. And they can introduce the distribution method this way. What I would do if I was an elementary teacher is I would start the box method as early as possible, because this will work their entire career. So what I see is I have one term here and I have two terms here. So what I did is I set up a 2 by 1 box. And what I'm going to do is we're going to take this first term that's here and put it on the one side, and then we have these two terms here, and we're going to put it here and there. And what we're starting to set up is the distribution property for this. I'm sure old school method, we kind of did this dance. I try and stay away from that dance because this one will help them more often than not as they progress farther in their math education. So when I do this, I'm going to do the row times the column and get a value here. So 3 times 5 is going to be 15. Then we do row times column here. 3 times 7 gives me 21. And they're both positive numbers, so I would write 15 and a positive 21. And we will put those together and get 36 as our total. That is distribution in a nutshell and box method. Could work as well with negatives. So let's try. Actually, let's pull this and they'll do 5 minus 7 as opposed to 5 plus 7. So we'll put our 3 and we'll do 5 take away 7 or 5 minus 7, however you want to read it. We have one term by two terms. And we are just going to draw our box. I don't know why it's yellow and green, but it is what it is. So we have a 1 row by 2 column box. And once again, we're going to put our numbers in place. So our 3 goes here, and then our 5 and 7 go here, and then the 7 is negative, so we're going to put the negative with the 7. So now, once again, we go through our process of multiplication, row times column, and that's going to give us 15, and then row times column again, and 3 times negative 7 is going to be negative 21. Now, if we read it and write it, we're going to do 15 take away 21. However, think about money. Money is kind of the perfect sense. So if we start, and you have some money in your savings, but we start at ground zero, and then I come around and I give you $15. You have made a profit of $15 right now. But then you have to give me $21. At that point, you have to give me my 15 back and then go into your pocket and start digging out of your pocket money, and you start to go in what we call the hole, or we go into the negatives. The quickest and fast way I tell my students is just subtract the two numbers. I don't care what two numbers they are, but always take the biggest minus the smallest. Okay? So if I do 21 minus 15, we are going to get 6 is our solution, no matter what. Okay? And then I say, what number's bigger, 15 or 21? Which was the bigger number? And they'll obviously say the 21. And I'll say, what's the sign in front of it? They'll say negative. I say, let's keep it. And that's how I combine my positive and negative numbers together. Just a bit of a trick that I've learned. So if you have two numbers that are different, no matter what, and we could do negative 15 plus 21. If that was the case, subtract the two numbers. Okay, we're still left with 6. Which number is bigger? The 21. What's the sign in front of it? Stays positive. Now, if the signs are the same, just like this problem, 15 plus 21, that gives us 36. If it's negative 15 minus 21, signs are the same. Add the numbers together, only keep the sign this time. And it becomes a negative 36. So when you're dealing with the same signs, always just add them together and then take the sign for whatever it is. If you are subtracting them or they're opposite signs, subtract the two numbers and then take the sign in front of the largest one. That's the tip and trick of the day. And understand when we're doing this, all of this was just adding and subtracting numbers. Once you start multiplying and dividing negatives, that's when there's those rules that come into play with multiplying and dividing. So don't confuse multiplying and dividing negatives with adding and subtracting them. All right, so why and how does this build into bigger, more complex math? Well, what we can do is we can still take that 3. We can do 5 plus 7 again, only this time we're going to change it to a 5x as opposed to just a 5. So we're still doing the distributive property. Everything stays the same. There's just a variable in the mix. And when we talk about a variable, we're talking about a letter. And a letter represents an unknown number. Like if this was equal to something, then we could start to solve that. But right now we're just dealing with this expression and we're trying to simplify this expression. So make it a little bit easier to look at. Okay. So let's go on and do our highlights. We have a 1 by 2. So then make 2 highlights. I always just got in the habit of doing the first parenthesis, first term along the row side, and then the second parenthesis along the top side. So there's not a wrong way to do it. 2 times 3 and 3 times 2, no matter what, gets you the same answer. So whether we do it 3 along the row side or 3 along the column side, as long as we set up our rectangle properly. Actually, why don't we, just because, let's do it. Let's set it up both ways and let's see what happens. Okay, so now I've got the 1 term here and then the 2 terms along the side. So our 1 term is a 3, so we're going to keep the 3 there. And then our 2 term is 5x plus 7. And we can do 5x plus 7. Either way. Now, once again, start with our process of a row times a column. And we're going to do 3 times 5, multiply the numbers, and then bring the x down. And if you, it's how you have to think of this. What we're doing is we're doing 3 times 5 times x. And if we were to plug a number in for x, we would multiply it together. But we don't have a number for x right now. X is just x. So when we do this, we're going to do 3 times 5, and we're going to get 15. And we're still going to times it by x. But for mathematics and aesthetically pleasing things, they don't put that dot there. They just write 15x. So we're still multiplying. If we ever did have to plug a number in for x, they just don't show it. So when you see this 15x, really it's 15 times whatever our x value is. And they start off writing it like this, 3 times 5 times x, but it just gets simplified to 15x, which is what we're trying to do with the distribution property as well. We're just trying to clean this up and make it look as, once again, aesthetically pleasing as possible, making it look as pretty as we can. So then the last one, 3 times 7 is a positive 21. So let's try over here. Row times column. 5 times 3 is 15. Bring the x, and then 3 times 7 is a positive 21. And if we rewrite these two terms, we get 15x plus 21, or if we rewrite these two terms, 15x plus 21. Now, see, we get the same answer either way. These are both equal. What we cannot do, and think about this, if we have 15 times x plus 21, don't we need to do multiplication and division before addition in the order of operations? Remember, please excuse my dear Aunt Sally, where these two are on the same level. These two are on the same level. We work left to right. I think we talked about this before, but we work left to right. So if it was like -5 plus 2 minus 7 plus 10, we work left to right as we go through this. It's kind of like a stepping process. So we would do -5 plus 2, then we would do -7, then we would do plus 10, and whatever the answer came out to be, that's what it is. You always just want to work left to right. So, I threw it up on TikTok, like, I don't know, maybe it was last week with the order of operation little goof. And people got a kick out of it. But yeah, these are left to right. So if we were to do that, we definitely need to do the multiplication for the division. So what we cannot do is say that this is 36x, because that's something totally different. So, and well, why would you say 36x, Schmidt? Well, because if I added 21 to 15, I would get 36. But it's not 15 plus 21, it's 15x. So it's a little bit different. So the final answer and what makes it look the cleanest is this right here, 15x plus 21. To step it up one more time. What if we were to do 3x times 5x, and we'll bring that negative back into play. Let's have some fun with some negatives. So when I do this, I've got a 1 by 2. I'm going to do 3x. 5x minus 7. I just have a tendency myself when I do this to set up my box using what I do. So that first term goes down here. Those two terms, and that almost helps me set up my box so that I do it right as well. Okay, so let's take row times column. So 3 times 5 is 15. And we have an x times an x. And if we think about this in terms of numbers, 3 times 3, everyone's going to tell me is 9. But we also start to think about exponents. 3 to the first power and 3 to the first power. If we add those exponents together, we get 3 squared. Because 3 times 3 is 9. The exponent tells you how many of the big number you have. And if I put 3 squared into a calculator, I would get 9 out. So when we start to think about this process, what it's doing is it's taking the number, our base number, our 3's, and each one of them has a 1 exponent, and we're going to add them together. And when we do that, we get 3 to the second power. And that just kind of tells us that we have this number of base numbers multiplied together. Which, I know it's a bit tricky, but what I'm trying to get to you is when we do this. Oops. Oh no. Let's fix that. Sorry. Accidentally clicked the button on my pen. What I'm trying to get to is this right here. Why has this become x squared? Because when we have x to the first and x to the first and we multiply them together, we actually have an x squared. And then we're going to do this row times this column, and a positive times a negative is a negative. 3 times 7 is 21, and then keep the x. So that this becomes, as of right now, our final cleaned up expression, 15x squared minus 21x. And that's our cleaned up expression. It's no different than this one. It just looks different. And I know that sounds convoluted, but really this is one way to look at it. This is another way to look at it. And one of the things I like to tell my students is, what letter is this? What letter is that? What letter is that? You know, there are 3 different ways to look at a letter F. Then there's more than that, of course, with different alphabets and stuff. But I'm just trying to give this example of, like, there are 3 different ways to say the letter F where people are still going to understand that. This and this are 2 different ways to look at the same expression. Even though they look a little bit different, they still mean the same thing mathematically. This is still a 15x squared minus 21x. So is this. It's just factored out. All right. Then last step, if we want, and this is where I take my students, is going to multiplying these together. So now I've got 2 terms by 2 terms. So that when I set this box up, I now have 2 columns and I now have 2 rows. And I've got an x plus 3. I've got an x plus 7. And then I multiply the row times the column. Row times the column. Row times the column. And then row times the column. Oops, I screwed up here. My bad. Jumping ahead, x times 7 is 7x. Apologize for that. But mistakes and wrong answers are opportunities for growth and learning. I'd love for somebody to call me out on my mistake. That means you're starting to understand the concepts and what's going on. Plus 10x, so we're going to combine those 2 like terms. We still have an x squared, and we still have a 21. And once again, this really is the same thing as this. It just looks different. All right. Well, I hope you had a great time watching, and I hope you learned something. Please join Math Dragon Tutoring, the Discord channel, or subscribe to the Twitch channel. But feel free to ask questions away. I free live stream on Mondays and Wednesdays from 8 to 9 o'clock. I just want to spread the math knowledge as much as I humanly possibly can. So have a blessed day, and hopefully we'll get questions soon. Okay, so we'll keep this open. Stop.